SwayamPrabha. Digital India. Educated India. SwayamPrabha. Digital India. Educated India.
Hello everyone, let us have a look at the airport system. Before we start, let us first understand the definition of a system. A system essentially means a group of things or parts or components that work together in order to achieve a specific goal. So, the question arises, is airport a system in that way? Yes, it is a system, because it has got several components, and the goal of an airport system is to ensure safe operation of aircraft to transport the passengers with their baggage and or cargo. So, there are two main subsystems in the airport system, which are generally called as the airside area and the landside area. So, we will now look at each of these two subsystems in little bit more detail, and then we will look at airport as a system. First, the airside area. This is the area or the component of an airport where the aircraft are operating. So, we do not expect passengers to be present in the airside area. It is unsafe for a passenger to be in the airside area. So, the airside area is also called as the airfield system or airfield subsystem. It consists of aprons, taxiways, runways and the arrival and departure airspace. We will explain in detail what is meant by all these components of an airport. For example, an apron shown here is the location where the aircraft is parked as it is ready to receive the passengers before takeoff, or where it delivers the passengers after landing. Taxiway is the link between the apron and the runway. So, all these are aircraft parked in the apron area. This is the runway, and the interconnection between the apron and the runway, such as these areas, these areas, these areas, they are all called as taxiways. Taxiways are the roads on which the aircraft proceed from the apron to the runway, or the roads which are used by the aircraft to exit the runway or after exiting the runway and moving towards the aprons. Then we have runway, which is shown here in this wide length marked with the center line, and you can see there are two aircraft which are there on the runway. Generally, we do not allow more than one active aircraft on the runway at any given point of time. Only when an aircraft exits the runway to the taxiway only then we allow the next one to enter. Till that time they have to wait in this area which is called as the holding area. And then after runway there is a arrival and departure airspace. This will be the arrival airspace, this will be the departure airspace. Both of these are also part of the airside area. Then we have the landside area. The landside area is the place where we expect passengers, their vehicles, the guests, receiving people. We do not expect any aircraft in the landside area. It is dangerous for the passengers to be in the airside area, and it is dangerous for the aircraft to be in the landside area. So, this is the component where the passengers or the cargo are expected to be present and operate. It is also called as a passenger terminal. So, it consists of the approach to the airport or the approach roads to the airport, the terminal parking where the vehicles are parked which come to receive the passengers or to drop the passengers, and the terminal building where the passenger enters for the check-in counters, for the security, and if it is international, for the customs. Even the duty free area is also inside the terminal building after the immigration and customs. And then you have the gate, which is the last place where the passengers go. So, gates connect to the aircraft or gates connect to the apron by the ground transport or buses. Okay. This image is that of Dubai International Airport, and in this case the demarcation between the landside area, which is the passenger terminal, and the airside area is very simple. It is just this straight line, the red straight line. So, this is the approach, this is the terminal building, and inside it you will have all the other things like the check-in counters, the security, the customs, immigration, etc. And these are the gates at which the passengers are fed inside the aircraft. So, then you start the landside area. So, these are the aprons 1, 2, 3, each aircraft is parked in one apron. Then there are these taxiways which will connect, taxi lanes actually, which connect to the taxiway, and then the taxiways connect to the runway. Here is the runway on the bottom left. So, in this case the demarcation between the airside and landside is very straightforward and simple, but it may not be the case in all airports. For example, here is the Chhatrapati Shivaji Maharaj International Airport, and this is the broad layout of the airport. Now, in this airport we have cross runways, and the landside area is at two places. There is one here which is the terminal 2 where we have the international airport, and there is one here which is terminal 1 which is the domestic airport. So, the area encompassed below these red lines is the landside area where we expect passengers and the supporting facilities, and the entire other area is the airside area consisting of the. So, these are the aprons. Okay. Then we have these taxiways, taxi lanes, this is the main taxiway, and then you have the runway. This is the main runway and this is the secondary runway. This is the layout of Chhatrapati Shivaji Maharaj International Airport Terminal T2, which is the international terminal. We notice here that the layout of this terminal is in the form of multiple fingers. This is the departure terminal for international flights, and you can see the areas marked in green color can be reached within 5 minutes of walk after entering the concourse. The areas marked in the purple color can be reached within about 10 minutes. Okay. So, it is a very convenient airport, and of course, there are these golf carts also available to take the disabled or elderly passengers or passengers who need support. This is the terminal 2 level 3, which is the domestic departure area. In the domestic departure area we can see that As you come in, this is the approach road to the airport on the bottom. There are different lanes for private cars, for taxis and for government vehicles. And then these are the blue lines here are the check-in counters A, B, C, D, E, F, etc. After that you come to the security, and since this is the domestic terminal, after security we simply have the terminal, and then you can see that there are some areas which will need 15 minutes like this area shown in the red color. The ones which are shown in the green color, these will need about 5 minutes, and the ones shown in the purple color will need about 10 minutes. So, this is the layout of the airport for the domestic departures in the terminal T2. Another interesting airport, which is the third largest, third busiest airport in the country, is after Delhi and Mumbai, is the Kempegowda International Airport, which serves the city of Bengaluru and the nearby areas. This airport has two parallel runways, each of which is 4 kilometers long. So, you can see this is one runway and this is the other runway, and then you have these taxiways. Okay. You will notice that some taxiways are inclined, whereas some taxiways are almost perpendicular to the runway. You can see here also these two are inclined, these two are inclined, and this one is at the end. So, we will study about the taxiway angles and orientations when we look at the design of the airfield. Kempegowda Airport was the first airport in the country to come up with complete contactless travel right from approach of the passengers to entering the aircraft without touching anything during the COVID-19. So, here is a very interesting video that shows how it was done. As you can see now, the passenger is approaching, and the web check-in happens online on the phone, right. This is the approach of Terminal 1 of the Bengaluru International Airport. This is the departure gate. So, they have introduced a thermal scan and the Arogya Setu app, which allows you to be scanned and enter the airport without any need to touch anything. Scanning of the boarding pass, holding up the ID for verification. Scanning of the QR code. Printing of the baggage tag. You can either drop it on a self drop zone or you can drop it at the assisted zone. Once again, when you enter the gate security, you have a contactless scanning. So, this is an example of how contactless travel was achieved at Bangalore airport during the COVID-19, and the system is so efficient that it is still working. Moving ahead, let us look at what are the factors that affect the size of airside area of an airport. The first and the foremost factor is the number of runways, the number of taxiways and the aprons which are required to be built at an airport. Obviously, if you have less number of runways, maybe you have only one runway or you may have 5, 6, 7 runways. The largest number of runways at any airport in the world, as we shall very soon see, is at Chicago O'Hare Airport, which has 8 independent runways. Then the length or the lengths of the runway and their width or widths are the ones that decide the lateral dimension that will be needed. If the runways are parallel, then you may need lesser area, but if they are cross runways, then you need a larger land area. And also the orientation of taxiways with respect to the runways also is a big factor in deciding how much area is needed. And also the pavement's type and thickness, because as the aircrafts become heavier, you need to have a thicker pavement to take of the load, and there are two types of pavements. There is a flexible pavement and then there is a rigid pavement. Plus the location of the terminal building. If the building is located within the within the two runways, then you have lesser area, but if the building is located on the other side or on the either side of each of the runways, then yes, you will need more airside area. So, how much land area is needed to construct and to develop an airport is a function of so many factors. Okay. So, these factors are kept into mind when we carry out what is called as an airfield design, and the aim of the airfield design is to ensure that the operations at the airport take place. Operations basically means takeoff, landing, etc., loading, unloading. They take place very efficiently. Good layout or a good airfield design results in flexibility for the airport operator. Then there should be always a potential for future growth. Airports always evolve over time, and generally as the city becomes more and more populous and the demand for travel increases, there is a growth. Sometimes there could be lull in the growth, there could be negative growth also, but by and large it is found that at most airports, if the performances are done very properly and efficiently, there is always growth. So, therefore, there should be potential for future growth. You should not be stingy in acquiring the land for an airport, and later on what will happen is the development of other facilities near the airport, buildings, hotels, they can cause a great constraint on the operation of aircraft. So, therefore, one has to be mindful of the possibility of the growth. So, you need to acquire land in such a manner that at least you have positive control on what facilities come up near the airport or in the vicinity of the airport, so that the airport operations are not affected because of the developments near the airport. Then we need to adhere to standards and recommended practices when we go for the design of the airfield. Now, you might wonder, why do we need standards? Why can we not allow complete creativity to come in the play when we design the airport? The reason is twofold. One is primarily we want to ensure that the operations are safe, and in the process of trying to save the land or to optimize, you may cut corners and that may affect safety. So, there are certain guidelines given for the minimum runway width, the distance between runway and taxiway, the distance between the taxiway and the terminal, how much land should be available under the direct control of the airport on the lateral side of the runway. All these things are governed by certain norms and standards. Okay. And the other thing is that aerospace engineering and aviation is basically an international global system. So, if we have standards, then we have some uniformity. If we have uniformity, then the crew member or the pilots who operate, they will not get completely confused, they will know what to expect. So, the colors of the taxiway lights, the colors of the runway lights, the kind of signs and markings, all of them are generally standardized, so that it becomes very uniform. Any pilot operating from any country can visually have some basic idea. So, to ensure that the standards are followed, there are certain classification procedures and there are certain standards to be followed. There are two main standards. The first standard for airfield design comes from the Federal Aviation Administration. This is mostly applicable for the aircraft operating or registered in the USA, operating within the USA, and the other regulations is the International Civil Aviation Organization or ICAO, which are applicable on an international front, right. Now, both of them, they use very similar but not the same coding systems. So, airports are coded, and by looking at the airport code, you can make out which kind of aircraft can operate from that particular airport. So, both these ICAO and FAA, they classify the airport based on the most demanding type of aircraft which the airport is designed to serve. So, the parameters or combination of parameters from the most critical aircraft are taken to classify the airport, and once an aerodrome reference code or ARC is specified, then there are standards available from the manuals. So, what should be the gap between runway and taxiway, etc., all that is fixed based on the aerodrome reference code. Every country will adopt either FAA or ICAO regulations. We in India are adhering to the ICAO standards. Let us have a look at airport classification codes. First, we will look at the method followed by the FAA. So, FAA looks at the approach speed, V approach of the aircraft, which is generally 30% higher than Vstall at the maximum landing weight and the aircraft in the landing configuration. This is generally the case. The approach speed of the aircraft is typically 1.3 times Vstall or higher, so that there is a 30% margin. Stall speed is the speed below which the aircraft will not be able to sustain the flight, because the lift will not be equal to weight, it will be less than weight in a sustained manner. 30% margin is given. So, we do not want the aircraft to land just at the stalling speed, it is quite dangerous because there is no margin. So, we expect the aircraft to land at a speed which is around 30% higher than the stalling or the minimum permitted speed at this configuration. And the other important criteria that FAA uses is the wingspan, or the distance between the lateral distance between the wing tips of an aircraft. Now, ICAO on the other hand uses what is called as a reference field length. The reference field length is the runway length needed for safe operation of the aircraft under the certified maximum takeoff weight at the sea level conditions under the International Standard Atmosphere called as SLISA, no wind condition, no headwind, no tailwind, and the runway being level. Under these conditions, whatever is the runway length required for safe operation, that is called as the reference field length, abbreviated as RFL, and also it uses the outer main gear span, okay, which is abbreviated as BOMG, that is the distance between the outermost wheels of the main landing gear. Let us have a look at it. So, let us look at the ICAO condition. As I mentioned, RFL is the minimum field length required for takeoff at max takeoff weight, certified max takeoff weight, ISA sea level, still air and 0 runway slope. So, there are 4 code numbers. Okay. Typically, code number 1 stands for very small aircraft which require a runway reference field length of less than 800 meters. So, a typical example would be Dornier 200-212 aircraft, that would roughly fit into the code number 1. Code number 2 is if the reference field length is between 800 to 1200 meters. Code number 3 is if you are more than 1200 but less than 1800, and if you require more than 1.8 kilometers or 1800 meters, then you call it as code number 4. As far as the code letter is concerned, there are these letters from A to F. So, if the wingspan is below 15 meters, or if the outer main gear wheel span, that is the distance between the outermost wheels of the main landing gear as shown here, if this is less than 4.5 meters, then you come under code letter A, and code letter B is for wingspan more than 15 but less than 24, and the outer main gear span 4.5 and 6. So, if there is an aircraft which has got a wingspan of 15 meters, but the outer main gear span is more than 4.5 less than 6, it will be classified as B, because the more critical of the two is considered while we assign the code letter. So, the aerodrome code letter could be anything from A to B to C to D to E to F, F being the largest one, where the wingspan is between 65 and 80 meters and the outer main gear span is 14 to 16 meters. Notice that there is no category after this, okay, there is no G category. Therefore, by and large all the aircraft that you will see in passenger service today, they will have a wingspan less than 80 meters. There are a few exceptions like AN 225 which had a wingspan more than 80 meters, but that is not supposed to operate with passengers. That is basically a cargo aircraft. So, all passenger aircraft, they will try their best to fit the wingspan within 80 meters, and if the wingspan is going beyond 80 meters, they will have to incorporate very interesting mechanisms to ensure that when the aircraft is at the airport, the wingspan is not more than 80 meters by folding the wing tips. For example, in Boeing 777 they have employed folded wing tips to meet the criteria. So, what they have done is they did not want to go to code letter F. So, at 65 meters they have folded the wing tip so that the aircraft can remain within code letter E. What happens is that there are very few airports which can handle code F aircraft. So, if your aircraft is having a wingspan more than 65 meters, then its usability at many airports is not possible, and therefore, there will be a chance that the airline will not procure your aircraft because it is not going to be able to operate from many airports. So, many manufacturers try to fit within low categories. Okay. As far as the FAA is concerned, they use the reference aircraft approach category from A to E depending on the approach speed. Any aircraft with approach speed below 91 knots fits into category A, etc., etc., and they do not expect the approach speed to be more than 166 meters. Similarly, there is airplane design group from 1 to 6 depending on the aircraft wingspan. Here also you notice that 80 meters is the upper limit for airplane design group 6. So, let us look at some popular jet airliners which are categorized. So, the FAA aerodrome code letter 2 or code letter B for ICAO, an aircraft that fits in this is the Boeing 717, which is a small aircraft with approximately 100 seats. Then if you look at the aerodrome design code 3 and code letter C, the entire Airbus A320 family 318, 319, 320, 321, the entire 737 family 600, 700, 800, 900 and MD81, they all fall in category code letter C or ADC 2. Then if you look at ADC 4 and code letter D, these are larger. As you go from B to C, C to D, etc., the aircraft become larger in size. Similarly, aerodrome code 2, 3, 4, the aircraft become larger in size. So, the aerodrome design code 4 and the ICAO code letter D is the mid range aircraft like 310, 300, 757, 767, these are around 250 seater aircraft, they all fall into this category. And then you have ADC 5 and code letter E, which is the large aircraft that you see, the Boeing 777, the Boeing 747 as shown here, or A330, they are all coming under this category. These are aircraft with 350 seats or so, and the only aircraft that comes in code letter F or ADC 6 today is the Airbus A380 aircraft, which is the world's largest passenger aircraft flying today. You can see it is a massive aircraft with double decker fuselage from nose to the tail. Okay, so there is a total double decker and there are 4 engines. Now, let us look at 2 examples. One, airport designed for large aircraft, how they look like and what kind of features do they have, and also the airport designed for the small aircraft. So, for airport designed for large aircraft, I have chosen Hong Kong airport. So, you can see, if you zoom here, you can see that this particular terminal has this kind of a X kind of a configuration. So, you have these Y here and then you have another Y here. So, it looks like an X configuration, and you can see that there are these gates which are available for each of these large aircraft. So, if you are having an airport that is designed for large aircraft, then larger proportion of aircraft will be categorized in category 5 and category 6, and less of them will be in category 1 and category 2. So, here you can see there are few aircraft like this and like this which are small aircraft, all the other aircraft are large aircraft. Okay. Now, for Airbus A380 they had to knock off one of the gates because of the width and the size of the aircraft and also the number of passengers which have to be filled in. So, usage of A380 has led to many adjustments required at the airports, at existing airports. Okay. Here is an example of an airport designed for small aircraft. This is the Phoenix International Airport. So, here you can see that there are these 2 terminals, both are like the fingers, and all around that finger there are aircraft, and all the aircraft that you see are roughly of the same size. So, this airport normally services passengers with narrow body aircraft. So, that is why the layout is also in such a manner that more narrow body aircraft can fit in the space available at the airport. So, here the proportion of aircraft categorized in 3 and 4 will be high, and the proportion of aircraft categorized in 5 and 6, which is the large aircraft, will be much lower. As I mentioned, airports do not remain stagnant, they evolve over time. They grow in size, the number of runways may change, and they also undergo lots of alterations and amendments based on the circumstances. So, generally what happens in airports is that you add a runway parallel to the existing runway. Now, if you add this new runway near the current runway, then you cannot operate on both the runways simultaneously. There is a minimum gap of approximately 760 meters required between the center lines of the 2 parallel runways for them to be considered as independent runways, where you can have simultaneous takeoff and simultaneous landing at the same time. Okay. So, this is one general evolution over times. Then sometimes you start the airport with many multiple runways and then you remove some of the runways which are not so frequently used, or which are not, over a period of time the wind patterns also change, and because of that certain wind directions may become useless, and because the wind pattern has changed, so those runways may become useless. So, we can get rid of them, convert them into taxiways or do whatever else is required. Okay. Another important thing that is done when airports evolve is that as airport evolves, it wants to accommodate larger and larger aircraft. Larger aircraft being heavier generally require extra runway. So, one common development of an airport is to lengthen the existing runways. That is why, as I mentioned, it is important to acquire proprietary control over the rights of the lands at both the ends of the runway, so that you do not come up with a situation that you cannot expand. A case in example here is the Mumbai airport, where on one end you have the LBS Marg, on the other hand you have the Western Express Highway. So, it is very difficult for the main runway to be extended in both the directions or any direction. There is of course a secondary runway which does not have roads immediately at the both ends, but it has got various the land which is actually under the airport's control has been encroached upon, and therefore, not much expansion is possible there also because of the encroachment of the land. The other thing that is normally done is expansion of existing passenger terminal buildings. I recently flew to Kolhapur airport on an official duty, and what I saw is that as I landed there was a very small terminal building, hardly able to accommodate about 100 people, okay. But they are now building a fairly large sized passenger terminal next door, which looks quite large in size, and I was told that they will also start having night landing facilities, which will then allow more and more aircraft to operate, and also to operate at convenient times. For passengers, the most convenient time to operate is early morning and late evening. Early morning you take a flight and proceed to the destination, do your work, and late evening you take a return flight and come back home, or vice versa. Okay. But at many airports you do not have night landing facilities. So, therefore, operations can take place only between, let us say, 10 AM to 4-5 PM when there is good sunlight, and that is a big restriction on the scheduling of the aircraft. So, that is what I was saying, introducing new passenger terminal buildings. Bengaluru airport recently in 2019 got the second terminal, and similarly there are many airports which are also expanding. It is very important to keep in mind that when we plan an airport system, we have to do it carefully, because inefficient airport layouts can occur because of improper planning. Okay. There could be too many runway intersections. Each time there is a runway intersection, there will be delay in departure and arrival, because if an aircraft has to cross an active runway to go to the terminal building or to go to any other location, that causes delay, because an active runway crossing will require to ensure that there is no aircraft coming or going. So, therefore, you will have to hold the aircraft, wait till the runway is clear, allow the aircraft to cross. During that time, the departing or the arriving aircraft have to wait, and that compromises the safety of operation. It reduces the operating capacity. There could be suboptimal passenger building layouts also, which will require a larger taxiing distance. So, the building could be at one corner of the airport. So, the aircraft lands and then there is a long taxiway to the terminal, and if this also involves crossing the runway, then of course, it will take much more time. Then when passenger terminals are at two different locations and the connectivity between the two is not very good, sometimes you need a bus for connectivity. At some big airports like Munich airport, there are small railway connections. There are these trains which go between terminals. It is quite fast, but still you have to walk some distance and then wait for the train, then go to the destination, again walk some distance. I will give you an example of the London Heathrow airport, how it has evolved over times. At one point of time, London Heathrow was supposed to be the world's busiest airport. In 1952, this was the layout of the Heathrow airport, and you can see that there were so many active runways. There are 6 active runways. These 2 are the parallel runways, then these are parallel, and these are also parallel. So, there are 6 runways here in almost like a star formation. Okay. Then there were 3 more runways proposed. Okay. Probably the plan was that the small regional aircraft or turboprop aircraft will operate on these 3 blue runways, and the main runways will be used for the large passenger aircraft. That was the plan in early 50s. Come 1980, and it was decided that only the 2 runways shown in the green colors would be used, and the runways shown in the purple color, which are basically the crosses, they will not be used. So, you can see that only 3 runways are going to be used in 80s, and the 2 main runways are going to were given an extension at one end, because it was possible. There was no possibility here to extend it because you have the airport boundary, but here there was land available. So, there was an extension proposed here. Then this is how it looked like subsequently. So, 2 parallel runways and 1 more runway at the end, proposal given for the Heathrow airport. So, 2 existing runways and 1 more proposed runway. And if you actually see today what is the situation, it only has these 3 active runways. Okay. Now, these runways that you see here, they generally have some numbers at both the ends. As the pilot approaches to land at an runway, the pilot sees some numbers at the runway end, and those numbers indicate some information for the pilot. So, this is called as runway designation. Each runway is identified by a 2-digit number, and this number is a whole number, but it consists of to the nearest of the 1/10 of the magnetic azimuth of the runway center line and measured clockwise from magnetic north. So, depending on the angle of the runway in the landing direction with the geometric north, okay, that is used. For example, if the runway is inclined in such a way that when you land, the angle that you make is 220 degrees, right, this one for example, okay, that is 22. So, runway 22 means 220 degrees, and when you come on the other end, your angle at the end will be 40 degrees from the north. So, that will be called as 04. Okay. So, you will notice that each runway will have 2 numbers, one at each end. This one is called as 0422, and these 2 numbers will differ by 18 always, because 18 means 180 degrees, and you know that the 2 angles of a line are separated by 180 degrees. So, therefore, the numbers will always be separated by 18, and if you have more than one runway inclined at the same angle or similar angle, then for example, here you can see there are 3 runways, all of them are inclined towards 30 degrees, correct. So, they are indicated as either L or R if there are 2 parallel runways left or right, or there could be also, if there is a center one, you can have L, R and C, where L left, right and center. So, at many airports, as I will show you, you will find that there are multiple runways in the same direction. So, you have to use this kind of a numbering scheme. So, back to Heathrow airport, the main runway is 2709 L and 27R09 L. So, you can see that both of them are parallel. This is the north direction. So, it is 270 degrees and this will be 90 degrees, and there is an additional one which is 0523, okay, 50 degrees inclination and 23 degrees to 30 degrees inclination from north. Okay, let us look at airport layout. Okay. What are the factors which affect the land area of the airfield, or how much land is to be procured? So, as I mentioned earlier, number, orientation and geometry, separations between the 2 runways, what are the reference codes which are being used, where do you have the land side, and do you have area reserved for the future. It is found that between 80 to 95% of the land area or the airport area is occupied by the air side, and the remaining is available for the land side. Land side actually requires very small area. Now, if you look at the data about airports, you will find that there is a very weak correlation between the land area used by the airport and the amount of traffic actually processed at this particular airport. So, just because you have a larger land available to you at an airport, it does not mean that you will have higher traffic, not necessary, and vice versa. There could be very high traffic from an airport which is actually in a small land mass. Similarly, there is a very strong correlation between the land area of an airport and the potential capacity to handle passenger and aircraft. So, definitely larger land area means higher potential, because smaller land area will limit the growth of the airport, but larger land area does not necessarily mean that you are operating more efficiently. Okay. So, because there are large differences in air traffic demand at various airports globally, and let us have a look at them. So, in the recent study published in 2022 by the Port Authority of New York and New Jersey, which operate a few major airports in the New York area, they looked at which are the top 60 airports in the world, and they looked at two criteria: number of passengers carried and the cargo carried. So, when you look at the number of passengers carried, it is very difficult to read. These are the top 30 airports, okay, and the highest one being the Atlanta airport, and number 30 is the Logan airport. So, in this list, this is the top 30. In the top 30, you find that there are 16 airports which are in USA, and 2 of them are airports in India and airports in Spain. In India, the 2 airports are number 9 rank in the world is Indira Gandhi International Airport at New Delhi, close to 60 million passengers, and the next one is the Chhatrapati Shivaji Maharaj International Airport, which is number 28, that has got about 38 million passengers. Okay. Whereas the world largest airport Atlanta, it carries 93 million passengers. If you look at rank number 31 to rank number 60, you see that there are another 5 airports in the US. Now, Saudi Arabia, Turkey, Australia, they have 2 each, and one airport, which is the Bengaluru Kempegowda International Airport, is number 56. So, in top 60, India has 3 airports, keeping in mind the passenger capacity carried. At the Kempegowda airport, you have around 27 million passengers, 27 million, 38 million and 59 million. If we look at the freight, or if we look at how much is the cargo carried, you find that in the top 30 airports, the busiest one and the largest one is the Hong Kong International Airport. Okay. There are 9 airports in this list from USA, there are 5 from China, 3 from Germany, none from India, and in the bottom half of the 60, 31 and 37 are the Indira Gandhi International Airport and the Mumbai Airport respectively. So, USA has 11 in this list, China 3 and UAE and India have 2 each. Let us have a look at the layouts of some interesting airports and important airports, and this particular study will help us get an idea about the variety in the design of airports or the layouts of the airports all over the world. So, an example of 2 parallel runways which are close to each other is the London Gatwick Airport. Because these 2 runways are so near, 08L26R and 08R26L, because they are so near to each other, that is why we are not allowed to use both of them simultaneously. So, only one runway among these 2 is active at any given point of time. You can call it as one of them is active, the other one is standby, and later on the operations will move to the other airport to distribute the loading. London Gatwick happens to be the airport with one runway and largest number of operations per hour. Then you can have parallel runways supplemented by a third runway, and that is an example of the Frankfurt Main Airport. You can see you have one runway here, one runway here and the third runway here. So, these 3 are parallel, okay, but there is a reasonable gap between these 2, and then there is one more here which is offset or supplemented. So, most operations take place on this runway and also on this runway, but once in a while you also operate along this particular runway. So, these are parallel runways supplemented by a third runway. Another example of independent parallel runways with the terminal building in between is the Munich airport. So, here you can see in a very small land area we have operation of this airport. So, there are these 2 main runways both are parallel, but the gap between them or the lateral distance between them is so large that they can be used simultaneously because they are staggered. And this staggering basically means that the ends are not matching. This one is, you can see, it is staggered. Okay. Then when you have runways like this which are independent and parallel, you have many benefits, because the area between the two independent runways can be very efficiently utilized, as is the case in Munich. Such a small footprint accommodates huge amount of traffic. Okay. Otherwise, it will be underutilized. Then on both the runways there will be reasonable proximity of passengers and cargo buildings, because passengers can go either here or there from the center. So, it is very convenient. We are assuming in this case that the landside configuration and apron texture is as you can see in the Munich airport. Then there will be better airfield traffic circulation, because aircraft can reach either end of the runway without having to cross the active runway, because they are parallel and spaced far apart. So, you do not need to go to the other runway or to cross, you just remain yourself. It is like, this is something like operating two independent airports joined together. Okay. And in this way you can also isolate the airport's landside from the surroundings, because the entire landside area is now within the two runways. So, there is no chance of any encroachment or any other disturbance in the landside area from anything external. The two runways at the ends are having the boundary of the airport. Now, sometimes you need to go for intersecting runways, and here is an example of the New York LaGuardia airport, which has these two runways which are crossing. Okay. So, the terminal building is located on one side in this area. And also at Mumbai airport we know that we have a cross runway. So, you can see this is our main runway and this is our secondary runway, and they both cross. This is the terminal 2 which I already showed you, this is terminal 1, this is terminal 1, sorry. Now, Denver airport has 6 runways, you can count them 1, 2, 3, 4, 5, 6. So, these two are parallel runways. So, they can be operated simultaneously, and these two are also parallel, and the gap between them will decide whether they are able to operate parallelly or they are operated in they have to have dependent operation. These two appear to be quite near each other, so they will not be operated simultaneously. In this case, I have actually turned the figure 90 degrees just to tell you that north is this direction. Normally, when you see the map of the runway, you have to assume that the north is going up, but that would have actually occupied more space. So, therefore, I have just turned the figure around for you to get a better picture. Here is Denver airport, which has 8 runways. So, you have 1, 2, 3, 4 and then another 1, 2, 3, 4. So, you can see these 1, 2, 3, 4, 5, 6 are parallel runways, and these are 2 cross runways. One is a cross here and the other one is outside. These are also parallel. Finally, let us have a look at the 10 top Indian airports in the year 2022 based on the number of passengers which they carried. So, these are the 10 airports marked with the red dots, and now we will look at one by one each of them. The first or the leading airport in the country which has largest number of passengers is around 6.5 crore passengers, that is the Delhi airport. Next is the Mumbai airport, which operated nearly 4.4 crore passengers last year. Third is Bengaluru airport, which operated 3.2 crores passengers. Next is Hyderabad airport, just above 2 crore passengers. So, Mumbai operates double the passengers in Hyderabad airport, and Delhi operates double the passengers in Bengaluru airport. The next airport is Chennai, which just under 1.86 crore passengers. The next number 6 is Kolkata, 1.77 crore passengers, okay, which is nearly half of Bengaluru. So, Bengaluru has half of Delhi, Kolkata has half of Bengaluru. The next is Ahmedabad, just above 1 crore passengers. So, it is 6 times, more than 6 times is in Delhi, more than 4 times is in Mumbai, more than 3 times is in Bengaluru, and double is in Chennai, Hyderabad compared to Ahmedabad. Then we have Kochi, almost 0.9 crore passengers, 88 lakh passengers to be precise. Goa, 84 lakh passengers, primarily the tourists who come from all over the world to Goa to enjoy the beaches. And then number 10 is Pune airport, which has around 80 lakh passengers, 0.8 crore passengers last year. So, Delhi, Mumbai, Bengaluru, Hyderabad, Chennai, Kolkata, Ahmedabad, Kochi, Goa, Pune. This is the order in which we have the top 10 airports in India. Thanks for your attention.